Let's talk about declarative setup by taking a mono application as an example. In Kubernetes, we can create a deployment, secret, config map, and other resources either using a CLI command or by using a Kubernetes manifest file. And this manifest file can then be passed on to a kubectl CLI command to create the resources. Similarly, Argo CD resources such as an application, repositories, or Argo CD projects can also be declaratively written as a manifest and created using kubectl. In our earlier sessions, we made use of the Argo CD CLI and the Argo CD UI to create new applications by inputting the source and the destination data. The same can be created using declarative manifest. Let's assume this is the tree structure of our Git repository, which has a directory named declarative with two subdirectories named manifests and mono app. Within the mono app, we have an Argo CD application YAML file. This YAML file has the project name, the source field referencing to the desired state in Git by passing the repo URL, revision, and the path. This path is referring to the declarative slash manifest slash geometric or geocentric hyphen model directory, which contains two Kubernetes resources within the Git repository. So these two resources are a deployment and a service YAML files. This application also has a destination field referencing to the target cluster and the namespace. And we can also have an optional sync policy field as well. This application manifest can be created using a simple kubectl apply command. And if there are no errors, the Argo CD application will be created. And once it is created, and once you synchronize it manually, or if it gets synchronized automatically, it is going to pull the deployment and the service manifest from the Git repository, and it's going to create them on the cluster. So this is how we can declaratively define an application and maintain it within the same Git repository as well. Thank you. In this demo, we're going to understand how to manage a single Argo CD application declaratively. So far, we made use of Argo CD CLI and the Argo CD UI for creating applications. So within the UI, we defined the Argo CD application metadata along with the source and the destination details. So whenever you do this, at the back, it also generates a YAML specification. So similar to any Kubernetes, deployment or service manifest, even the Argo CD application manifests can be stored as resources declaratively on a Git repository, and we can make use of Argo CD to automatically create and manage those applications as well, right? So we can use this YAML specifications in Git repositories. So let's see how to create a single Argo CD application using Argo CD itself. So what we can do is, so within the GitOps Argo CD repository, so I have a declarative directory where, in this example, we are going to make use of the mono application directory, which is going to deploy and manage a single application. So if I go here, we have a geocentric app.yaml file. And this YAML file is specific to Argo CD application, right? If you see, the kind is application and the API version is Argo CD project. And it is going to be deployed to the default project. I have mentioned the source details, the repo URL and the path. I've given the destination target details, and I've also given the sync policies like, creating the namespace, automatic sync, self-heal as enabled. And it is going to fetch the manifest for this application from this directory, right? So within the declarative, I have manifest. Within the manifest, I have the geocentric model. So if I go to that directory, so let me go and show you what we have over there, right? So within the manifests, I have geocentric model in which I have two Kubernetes resources. So we have the deployment YAML, okay? And we also have a service for exposing the UI on a specific port number. right? So how do I create this mono application? So for creating this, you can use an argo cd application, or we can simply use imperative commands as well. So what I can do is I can simply let me just create an application here. Okay, so or we can create an application here manually, or you can also make use of the kubectl command prompt as well. Okay, so we'll use the kubectl command prompt because we have not used it so far. Okay, so let me just pull this repository into my Kubernetes cluster. Okay, so let me just quickly clear this and pull it. Okay, let me check. Okay, I already have this repository, so but I don't want. Okay, let me just. Okay, so within demo, I just want to clone this repository. Okay, so here I have the GitOps repository. So I want to go to, so it has all the directories which we have just seen in the UI. So let me just go to the declarative folder within which I am going to the Mono app. So here I have the geocentric application. So I can quickly create this. So this has to be created within the argo cd namespace. So I can use kubectl apply. Okay, I need to use -f and apply. So this is going to create the geocentric application. So I can simply use argo cd app list, right? Okay. So you can see that a new application, geocentric model app, has also been created. I can also use the kubectl -n argo cd get applications command as well, which is going to show me the geocentric model app is also been created. Okay, and it's also automatically synced because we have enabled it. So let's go to the UI and see what it has created. Right, if you see here, a new application has been created here, geocentric model app. So let's see what we have over here. Right, so this application, it pulled both the deployment and the service resources from the manifest directory, and it deployed the pod and the service. So we can access the service or the UI on the port 30682. So this is basically a solar system based upon the geocentric model, where it was assumed that the Earth was the center of the universe and all the planets, including the sun, were rotating around the Earth. So this is the geocentric model. And this is how the application got deployed. So we didn't create it using the CLI or the UI. We made use of a declarative argo cd application definition file, and we created it. Let's have a look at the argo cd's app of apps pattern. Declarative approach can be used to automatically create argo cd applications. Instead of deploying each application manually, argo cd's app of apps pattern enables us to programmatically and automatically generate argo cd applications. We can create a root argo cd application using the app of apps pattern. The root argo cd application points to a folder that includes the argo cd application YAML definition files for each microservice or application. The application YAMLs for each microservice refers to a directory holding the application manifests. The idea here is to create a single argo cd application and upload all of its definition files to a Git repository path. Let's assume this is the tree structure of our Git repository, which has many directories. Let's look at the app of apps YAML file within the multi-application directory. This is the root argo cd application in our example. This application source refers to the app of apps directory, so argo cd will try and create all the applications mentioned in this directory. So if you see here, we have three Argo CD application YAML files defined over here. So Argo CD is going to create all these three applications automatically. So let's see what we have in the Circle app YAML file, because if you see here, each application has its own directory within the manifest folder. So let's see what we have in the Circle app YAML file. It has a source field, which again refers to the manifest Circle directory. Argo CD will create or update this deployment and service on the Kubernetes cluster. In this way, Argo CD is going to create all three applications and deploy all of it to manifests. The same concepts can be used to manage any Kubernetes object and even Argo CD itself. Whenever an application definition is updated or created in this Git repo path, an Argo CD application will be updated or automatically created. In this demo, we are going to extend the Argo CD application declarative approach to create multiple applications. And this is called as app of apps pattern within Argo CD. So you will be deploying one application, which is in turn going to manage multiple Argo CD applications. So let's understand the Git repository structure. So within the Git repository, I have a multi-app, Argo CD application. So in this Argo CD application, you can see that it is going to use this source, and within this source it's going to take the manifests or the Argo CD application YAML files from the app of apps directory. Okay, so if I go to this specific directory, so let me go to declarative app of apps, and if you see, I have three Argo CD applications. So these are Argo CD application manifests. So if I go to the heliocentric app, it in turn gets the Kubernetes manifest from this path, like from the manifest part. Similarly, if I go to the geocentric app, it gets the manifest from this path, right? So what is this path? If I go to declarative directory again, I have the manifest. Within the manifest, I have three Kubernetes applications. Each has its own Kubernetes manifest, deployment, and a service. So when I create this app of apps Argo CD application, it will internally create three Argo CD applications, and these three applications will deploy three separate, Kubernetes applications. Okay, so let's quickly check this out. So in the UI, so let me just delete the geocentric model app, which we just created in the last session, because we will recreate this in this app of apps pattern. Okay, so this is deleted. So now let me go to, okay, so let me go here. Okay, this is not the cluster which I want to use. Okay, so let me clean this. So let me go to the multi-app directory where I have only one app of apps YAML file. So let me quickly apply this in the Argo CD namespace, right? App of apps. So as soon as I apply this, we'll be seeing in the UI that it's going to create 3 to 4 applications over here. So let's create this. Yes, this is created. In the UI, you can see that it has created 4 applications. It has created app of apps, geocentric app, heliocentric app, and the heliocentric model with no Pluto application, right? So first, let's check the app of apps application, which we just created in Kubernetes cluster using kubectl. So this is a Argo CD application which internally manages other Argo CD applications, similar to how Argo CD manages Kubernetes resources, right? So if I click on this geocentric app or heliocentric app, it's just going to show me the applications manifest, okay? And it's going to give you the complete, YAML details about that specific application. And if you want to check out these applications, I can go back to Applications tab, and I can see three applications: geocentric, heliocentric, and the heliocentric with no Pluto apps. So let's quickly access all these three applications, right? It deployed the service. So the first one, it's listening on port 31849. Let me just duplicate. I need three of this. The first one is the geocentric model, which we have seen earlier, where Earth is the center of the solar system. The next one, we'll try to access the heliocentric app. It is listening on port 31663, right? Where the sun is the center of the universe. I mean, the solar system and all the planets rotate around it. And the last one is the heliocentric app, but with no Pluto. Well, some people believe Pluto is not a planet because it's very far away and it also rotates in a reverse mode. So we also have this model as well, where you don't have Pluto as a planet over here, right? So these are the three applications, which were. Let's have a look at how Argo CD is going to deploy and manage Helm charts. Helm is a Kubernetes package manager. Helm chart is a YAML configuration that specifies a collection of resources that are already configured and ready for deployment in a Kubernetes cluster. Helm charts enable declarative application definitions, which is a fundamental principle of GitOps. Helm uses a repository service to store the Helm charts. Argo CD can deploy packaged Helm charts and can monitor it for new changes or versions. Let's assume this is the tree structure of our Git repository holding Helm chart. Using Argo CD CLI, we can create an Argo application and deploy the Helm chart by inputting the repo URL, path, and optionally setting parameters through the Helm set option. Argo CD can also deploy application from other repositories like Artifactory Hub or Bitnami Helm charts. In this example, Argo CD will deploy Nginx using Helm charts from Bitnami and overriding the parameters using values.yaml file. The same Helm chart can also be deployed using Argo CD UI. Within the UI, the Argo CD can connect to repositories over SSH, HTTPS, or GitHub apps. We can add the repository details like name, type, URL, and can also add access credentials if you're trying to connect to a private repository. Once Argo CD deploys the application or the Helm chart, the application is no longer managed by Helm. Argo CD is solely responsible for monitoring and operating the application. Executing a Helm list command returns nothing because now the application is completely managed by Argo CD. To view the application metadata, we can make use of Argo CD CLI and execute Argo CD app get command. It outputs Argo CD metadata along with the Helm repo URL and the version details. Thank you. We are going to deploy a Helm chart using Argo CD, and we'll also see how to deploy Helm charts from multiple sources. So within our GitOps Argo CD repository, I have a Helm chart. So this chart has three resources. It is going to deploy a config map, deployment, and a service. And it's going to use the YAMLs values.yamls file to replace this, templates, all the data in the templates over here. And if I go to the config map, you can see that it is going to pick the color of the shape from the values.yaml file. And in the values.yaml file, I have hard-coded some values over here. So for the time being, I've hard-coded the color as black for all the shapes, and the service is also of type cluster IP. Okay, so we can also override these values while we are creating an application in Argo CD. So for creating an application in Argo CD, we can either use the CLI or the user interface. In this example, I'll be making use of the CLI. So I've already copied the command. So let me paste this. And the command is argo cd app create the name of the application followed by the repository URL and the path. And in order to override some values from the values.yaml file, I'm using the helm set parameter to update or override the values like the replica count as 2, the colors for circle and square as pink and green, and also I'm overriding the service type as noteport, and this is deployed to the default namespace. Okay, so let's check this in the UI. So in the UI, a new Helm random shapes application is created. It's currently out of sync. So let's try to, create this, synchronize this. Okay. So let me click on synchronize. And it is going to, deploy all the three services. So let us quickly, check the app YAML specification. Let's see how it looks like. So if I go to the app details and if I click on manifest, so you can see that currently it is using Helm as the source. Earlier we were making use of Git, but now it is Helm. And you can also see the parameters which we passed using the Helm set parameters, right? So those are also added here. Okay, so let's try to access this application. So the service is listening on port 32142. And you can see that among these five shapes, so the circle and the square are having the pink and green color. Rest all are using black because we have only set the color, or we have overwritten the color for these two shapes, using the Argo CD, application. And moreover, once Argo CD deploys this Helm chart, so Argo CD completely manages the Helm chart, all right, or the Helm application. Even if you try to do a Helm ls, you won't able to see the application which we deployed because now it is completely managed by Argo CD. So if you want to know the Argo CD application metadata, so you can simply use Argo CD app get and the application name. So here I'm going to use Helm random tips, right? So here it's going to give you the metadata of your Helm chart, like, what is, what are the resources which were deployed, the health status, and the source and the target details. Everything will be mentioned here. Okay, so this is one way of managing and deploying Helm charts right from the Git repository. And the other option is Argo CD can also manage, Helm charts, which are part of Helm repositories. Like, one example is, we can make use of the Bitnami, Helm charts. Okay, so how you can manage and deploy applications out of these charts, right? So I can copy the URL of the Bitnami Helm chart. So it is a resource of, a lot of charts over here. So let's try to deploy one of the chart using Argo CD. So in Argo CD, let me go and create a repository or configure a repository. So we have two Git repositories. Now let's connect to the Helm repository. So here the type would be Helm, name would be Bitnami Helm charts. I would like to use the default project, and the URL is the charts.bitnami.com, right? And if the private Helm charts are, or the Helm repositories are secured using username, password, or the TLS certificates, you can mention them. So these are optional fields. So let me use connect. And yes, we have added a new Helm type repository. So let's create an application out of this. So let me just name this as Bitnami. So we'll be using the Helm chart or the Nginx chart within this Bitnami repository. So I'm just going to deploy an Nginx application. Okay, I'll just keep this as manual for the time being. Auto create the namespace, And if you see here, the chart is already applied here. This is of type Helm. You need to select the chart. So it's going to display all the charts which are part of this repository. So let me just, so there are a lot of charts over here. Let me just search or type for Nginx. And you can also select the version of the chart. It's also going to display all the versions over here. So you can decide which version you want to use. So I want to use the version 12.0.3. You can select the destination details. So let me just deploy this to a namespace called as Bitnami. And if you scroll down, now you have the Helm option because this is a Helm chart or a Helm repository. You can also modify all the parameters. You can override the parameters. All the parameters will be displayed to you here, right? So here, let me, change the service type. We don't have a load balancer because this is not a cloud-based service we are using. So we'll just change the service type to node port in this example, but you can override any other parameter as well, which is being displayed here. Okay, so once you make these changes, you can simply click on create, or you can also check how the YAML looks like. Okay, here you can see the source, the target revision, the Helm parameter which we are trying to override, only the service type, which is node port. So let's create this. Okay, a new application is created here. So let me try to synchronize this because we have only two resources in this chart, a deployment and a service. Right? So now both the resources have been deployed, or the pod is still being created. So let me get the node port of this service. So it is 31640. Okay. So if you see, all the resources are in healthy state, even the pod is created. So let's try to see if we are able to access the Nginx homepage. Yes, you can see welcome to Nginx page. So it means that the deployment was successful, right? So this is how you can manage and deploy Helm charts using Argo CD. And at the same time, even if you do Helm LS, even after now, you won't see anything which is being managed by Helm. So now both these Helm charts are managed by Argo CD. Okay, so you can do a quick Argo CD application get Bitnami Nginx app. So let me get the app name correct. Helm-nginx-app. Okay, right? So here, it's again going to, give you the metadata about the Helm chart and which version was, currently deployed. So that's how, Argo CD manages and deploys Helm charts. That's all for now. Thank you. Let's understand how Argo CD supports multi-cluster deployments. Depending on the installation type, Argo CD can deploy applications in the same cluster where it is running or to a different cluster based on provided credentials. What if we want Argo CD to deploy application to multiple clusters? The first step is, of course, we need to have an external Kubernetes cluster. This external cluster should be added to Argo CD for it to deploy applications. But how does Argo CD know about the external server? Argo CD gets the cluster credential details from the kubeconfig file. So we need to update our kubeconfig file and configure the external server by executing kubectl config set cluster, set credentials, and set context commands. Once the external cluster is configured in kubeconfig, we can execute the argo cd cluster add command with the newly created context name. Initially, it is going to warn us saying that this command will create a service account on the external cluster with full cluster level admin access. Once this is accepted, it will create the required service account along with a cluster role and a cluster role binding on the external cluster and add the cluster as a destination or target in Argo CD. With this is done, we can select the external cluster as a target or destination within Argo CD applications for deploying or creating the resources. We can check the list of clusters argo CD can deploy to by executing the argo CD cluster list command. And the credentials to external clusters or the API servers are stored as secrets within the argo CD namespace. Thank you. In this demo, let's understand how Argo CD can deploy applications to an external cluster where Argo CD is not installed. It's also called as multi-cluster deployment model. So for doing this, we need to have two Kubernetes clusters. So we currently have the demo cluster where we are doing all these demos, and I have another cluster called as the dev space cluster. Okay, so we will try to deploy applications to the dev space Kubernetes cluster. Okay, so within the demo cluster, I can check what are the Argo CD targets. So I can do Argo CD cluster list. And currently, we only have one target, which is the same target where Argo CD is currently deployed. So how do we add, additional external clusters to to this list? So for doing that, first of all, we need to have the external cluster as part of the kube-config file. So you can do a kube-config get contexts. And currently, I have the dev space context as well defined. If it is not defined, you need to make sure you define the dev space context within your kube config file. So once this is defined, you can simply use argo cd cluster add. So this command, it's going to take the context from the kube config, and it is going to enable argo cd for deploying applications to this cluster. So what I can do is I can do argo cd cluster add, and I can give the context, which is admin at devspace. So it's going to give you a warning saying that this is going to create a service account on the external cluster. And apart from the service account, it's also going to create a couple of cluster roles and role bindings. So let me just click on yes for the time being, and it is going to create the required service account and the cluster roles in that external Kubernetes cluster. Once these are created, you can check the cluster list, and you should be able to see both the clusters added as targets in argo cd. So where does argo cd store this kube config details? So these details are basically stored as secrets. So I can do a quick argo cd get secrets, or let me say secrets, right? So here, if you see here, there is a secret added just 34 seconds ago, which is the cluster hyphen the IP of the cluster. Okay, so let's try to see what data was stored in the secret. Okay, so I can say cluster, I can say hyphen o JSON, right? So it is going to store the name of the server, the name, the server, and also the certificate as well. Okay, so let me just decode the server over here. So let me just say jq data dot server. Okay, so let me just base 64 decode this. Right, you can see the IP address of the external Kubernetes cluster over here, right? So this is how it's going to store the Kubernetes credentials. Okay, so how do we deploy application to this? So now within the UI, so let's say I want to deploy a new application, so I can just give the application name as multi-app demo. Let me use default. I'll just use automatic sync policy, auto create namespaces. For the repository, I'm going to use the GitOps Argo CD repository, and I guess I'll deploy, let's say, the geocentric application in the external cluster. So let me just go to manifest, right? So this is the geocentric model manifest. So let me just copy the path. Okay. And now comes the destination part. So now if I, okay, so now if you try to click on the cluster URL, so you should be able to see both the cluster target options available here. So let me just select the external cluster IP address, and I want to deploy this to a namespace called as multi-cluster demo, okay, just for demo purpose, okay. And I can go ahead and create it, but before I create it, so let me just check if there is a namespace available within the external cluster. So if I go to this external cluster, the dev space cluster, let me just take, so there is, so let's just see. So we don't have a namespace called as multi-cluster demo within the external Kubernetes cluster. So let's create this application and see how Argo CD is going to create the namespace and also deploy the application. So let me create it. Okay, so app path doesn't exist. So I guess, okay, this is within GitOps Argo CD. Let me just check the path once. It is in the declarative path. I'm not sure why it's not able to take this. Okay, so since I'm not able to make use of this path, I'll just use the Solar System path. I hope it works. And let me create the application. So if you see here, the multi-app demo is currently being created. It should be actually multi-cluster demo. I misspelled it. So here the application is deployed successfully. So let's go and check if we created, or if Argo CD created a new namespace. Yes, it created a namespace. So let's try to get all the resources which we have in this namespace. So 25 seconds ago, it created a deployment, a replica set, pod, and a service. And the service is listening on node port 32646. So let's try to access this. So this is the IP address of my dev space cluster. So let me get 32646. And yes, I'm able to access the application, right? So this is how Argo CD is able to deploy applications to an external cluster as well. And this application is not deployed in the demo cluster. It is deployed to the dev space cluster, which we can also confirm. So this is currently in the dev space cluster, and within our demo cluster, if I try to do kubectl get namespaces, we don't even have the multi-cluster namespace over here, right? So that's all for now. Thank you.